So the high voltage would cause a spark, which would give an engineer an electric shock. So the idea of a spark being caused, and the idea of this causing some sort of hazard to an engineer working on it. Okay, we'll move on to question 6 now. So question 6 is a question about nuclear fusion. So nuclear fusion power station. So explain what happens during nuclear fusion. So nuclear fusion is the formation of a large nucleus. Lots of people said we're mixing up the word nucleus and nuclei. I didn't penalise that in this exam, but it could have been penalised, so I had to make a decision about whether or not to penalise it. So it's the formation of a single large nucleus from small nuclei. So that's plural, there's more than one. So you need to be clear on whether you're talking about one nucleus or two or more nuclei. Many people were able to get that. Few of you were able to state that results. This is resulting in a loss of mass, which is something that we as a physics department are reflecting on in terms of that emphasis. So we'll be talking about that a little bit more when we teach that, when we revise it. So it's only 1 mark, but it's worth mentioning. That is true. And the release of energy. So it's mass being converted into energy, and at A level we cover that in a bit more detail when we do E equals mc squared and something called the mass defect. So diagram shows how a fusion power station could supply the national grid in the future. So a fusion power station, step-up transformer, and then we have a pylon. And those values are then needed in this next question, which is a calculation. So the fusion power station could supply the input coil. So we've got a current. So we've got a current. So it's the input. So the current is 28,000 amps. Voltage is 21,000 volts. The output coil has a voltage, so I'm going to call that V2, and I'm going to try and find I2. So that is V2 is equal to 330,000 volts. So the powers on either side will be equal, and the ratios will be equal. So I can state that V1 I1 equals V2 I2. So that statement should be correct. And then I can substitute in the numbers or rearrange first. I'm going to rearrange first. That's my preference. You don't have to rearrange first. You can substitute first if you wish. So we get V1 I1 over V2. And then the V1 is 21,000. The I1 is 28,000. Divided by 330,000. Now this is a step-up transformer, so the current should go down. So I should be getting a current that's significantly less than 28,000. Okay, so let's see if I do. So 21,000 times 28,000 divided by 330,000 is 1,780. But it's in kiloamps, so it is equal to 1,780 amps, but that is 1.8 kiloamps. So just watch out for that. So that then is our recommendation would usually be to convert them from kilo into the sort of standard number. In this case, you can sort of not spot that at all and still get the right answer. A number of you, I think because these two numbers were similar, you mixed up what were currents and what were voltages.